Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
So in the last video, we handled problem E for the R project. It was regression analysis, but we didn't do any regression analysis per se. We didn't deal with the numeric variable that was independent, and so that's what we're going to do now. This is part 2 of that video. And we have already loaded the data from the R dataset lists, and it's an MPG data. And we have already done quite a few graphs. And now we're going to do the first graph that has to do with engine display right here. The engine displacement with highway data, highway mileage data. So let's do that. We have the code right here. So this is plotting displacement versus highway mileage versus engine displacement. So let's run that code, and there is some correlation. Let's zoom that in. So there is some correlation. It's basically correlated. Negatively correlated. So as engine displacement increases, highway mileage decreases. We've also color-coded the cylinders. So the purple ones are 8 cylinders. They're the least economical cars, and these are the 5 and 6 cylinders, and these are the 4-cylinder cars. They are the most efficient. What we can see is the fit is not very accurate, because it seems to be going up this way and then going back out this way. So there is sort of like a curved relationship that we are not catching with this linear regression. Maybe we can do better by changing the engine displacement somehow. I think an inverse would be a good idea. So, but before we do that, let's look at the city gas mileage versus engine displacement. Let's run that and see if we see a similar situation. And here's a zoomed out data, and yeah, so there is some linear correlation, and it's negatively correlated as we expected. And there's this phenomenon here, curve phenomenon, that we are not really catching with this linear regression. So what we're going to do next is we are going to take the inverse of the engine displacement and put it in a variable in the data set, the data frame, and that's the code for that. So let's run that code. So this puts the inverse displacement in the MPG data frame. And then we're going to use that data to plot against highway mileage. Let's run that code first. And yes, this whole data is actually going linearly upwards. This is highway mileage versus 1 over engine displacement, and the unit is 1 over liters. But it is pretty accurate. It is going up in this direction, and uniformly around the line, the dots are scattered. So this line is pretty much the center of the scatter data. Okay, let's do the last plot, which is city mileage versus the inverse of displacement, engine displacement. Let's do that. And as expected, because in city and mileage and highway mileage are correlated, we are seeing very similar linear progression. There is only one part of the data which is highly uncorrelated. It's like outlier, but rest of it is sort of, the line is centrally situated to the scatter data, if you will. And yeah, and the gray section is standard error for the regression line. So it's showing that the line could exist between this point and that point, or this point and that point, but and over here it could be passing through those points, but that's about all. It's very narrow, and so we did a good job here. The data was pretty good, and I think I'm satisfied with the solution that we have provided here. The R code will be available online. Thank you for watching. Come back for the next project.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.